This demonstration is meant to go along with the synthetic division example 1, because I'm using the same problem. I'm just going to solve it two different ways. So with this particular demonstration, I'm going to solve it using long division. Now, the long division of polynomials is really similar to long division of just regular numbers. You know, you have to have certain columns, you know, like a hundreds column, a tens column, a units column, except in this case, your columns are determined by the exponent in your terms, and you need to have all the columns present. So x to the third, x to the fourth, x to the third, x squared, x to the first, and then your constant. And you set it up like this. X to the fourth minus 6x cubed plus 10x squared minus 10x plus 12. And of course dividing by x minus 2. I like to do a little trick here because I like to keep my columns all straight, and I like to keep my negatives all straight as well. So what I usually do is I go ahead and add the opposite. I change all of these subtractions to additions. Okay. The reason I do that is because wherever I see a plus sign is where I put a column. And I go ahead and use a pencil just to go ahead and pencil that in. And it helps me to keep straight all my columns, and I know exactly what's in the column as well. So this is a negative 6x cubed, for example. That's a minus 10x. Now let's go ahead and start our long division. The way long division works is similar, like I mentioned, to long division of regular numbers. I start with this space up here and I ask myself, what times x will give me x cubed? Excuse me, gives me x to the fourth, and the answer is x cubed. So I put that up there. And then I have to be careful to multiply both of these parts and put them in the correct column. So x cubed times x is x to the fourth. X cubed times a negative 2 is minus 2x cubed, and that goes in the x cubed column. So one more time. What times x gives me x to the fourth? And the answer is x cubed. So I multiply that times that and put that there. I multiply that times the second part of my binomial, it's negative 2, and I put it in the negative 2x cubed, or the x cubed column. Let's go ahead and subtract those just like you do in regular long division. That minus that is 0. Now if you do this correctly, your leading terms will always be 0 when you subtract them. This part's a little tricky. It's negative 6x cubed minus a negative 2x cubed. Now off to the side it would look like this. That's actually adding the opposite. So I really get a negative 4x cubed. And that's what I put down here. That's a problem for a lot of people. A lot of people want to put like a negative 8x cubed or a positive 4x cubed or something other than the correct answer. Off to the side, just go ahead and write negative 6 minus the negative 2 and get the negative 4.
May I have your attention, please? Joey and George Wagner to the Dean's office, please.
Let's continue now. Let's bring these guys down and continue on. What times x gives me negative 4x cubed? Answers minus 4x squared. Multiply that. Multiply the second part. Negative 4x squared times negative 2 is a positive 8x squared. Again, when I subtract those, I'll get 0. Remember, negative 4 minus a negative 4 gives me 0. 10 minus 8 gives me 2. Bring down the x squared. That just comes down, as does that. Start all over again. What times x gives me 2x squared? The answer is plus 2x. So that times that, 2x squared. That times the negative 2 gives me negative 4x. Now I subtract. Again, be careful here. Negative 10 minus a negative 4. Add the opposite, and you get negative 6. So this becomes negative 6x. Bring down the 12. Almost finished. What times x gives me negative 6x? The answer is minus 6. So I multiply, get negative 6x. Multiply that, and get positive 12. Subtract, subtract. I get 0 on both of those. That means that this remainder is 0. Another way of looking at that is that this factor times that factor will give you that polynomial. So in other words, it came out even. If you check this answer against the synthetic division example 1, you'll see you arrived at the same answer. I think you might find the synthetic division a little easier, but long division is just as easy once you get the hang of it. Okay, good luck.